to this. Okay, so day 6, we're going to do linear functions and systems today. Okay, linear functions probably will be a little bit of a review. The systems is one of those things that takes forever on a problem, so we want to get really fast at those. All right, so first thing, what is a linear function? Well, a linear function is really basically something that grows at a constant rate. If something grows at a constant rate, we're looking at a linear function. Okay. Every day I get $2 more in my bank account, that's linear, right? I spend $8 a day, that's linear. Every day I go buy 1 new cat, that's linear, okay? Linear growth or decay. So equations, right? We've got 2 basic kind of equations, y equals mx plus b and ax plus by equals c. This is called point slope, and this is called standard form. Either way, there's no exponents, right? It's not like x squared. There's none of that. There's no 1 over x. There's nothing funky going on. Just really simple, a number of x's, a number of y's, and a number, that's a linear function, okay? So as far as equations go, those 2 are going to define linear. An example would be y equals negative x plus 6, and here maybe 3x minus 2y equals 12. Those would be examples of each of those types, okay? Again, those are just, you want to be able to recognize a linear function from an equation. So this thing here, right? 110, 212, 314, 516, right? We're growing by 2 each time. And notice, why don't we grow by 2 here? It's because we didn't grow by 1 here. But this is still constant. Every 2 days, we would grow 4. Sorry, that's supposed to be an 18. Trick myself. So 14, 18, you jump 2 because you jump 2 here. You're doubling, you're adding 2, and then since you went 2 days before you wrote down the number, you go 2 times that. Okay? All right. So that is what makes a table linear. You can see this constant growth. Again, we're referring back to this word, constant rate of change. And what about an equation? Well, obviously linear looks like a straight line, okay? You can have horizontal lines, you could have vertical lines, you could have lines that go up and lines that go down. Anything straight is linear. Okay, so in this mx plus b, this is our most common one that they're going to ask about. We've got to know what m is, and we've got to know what b is. M is going to be the slope of the function. It's how fast this thing is changing. For example, if I go out to the store and I buy 2 new cats every single day, my rate of change, my slope is 2. It's the amount every single day. Now, students don't think about that, but like when it's 5/3 x, I increase 5/3 every day. That's what that means. It means I go up 5/3 every day. Okay? B is going to be the y-intercept. It's basically the starting point. It's where the function starts. So you're going to see when we graph these, you start with the y-intercept and then you use the slope to find another point. And we don't use 5/3 because it's hard to put a dot exactly at 5/3, having gone up 5/3 every day. So what we do instead is we realize that if I add 5/3, how many 5/3 will I have to add until this number that I'm adding is normal? Well, it takes 3 5/3. That's 15/3, which is 5, okay? So it takes 3 groups of 5/3 to make a whole number. That's why we go rise over run. We say the rise is 5, the run is 3. It took 3 days to go up 5. That's why we do rise over run, because it just makes a whole number here and a whole number here. And it's just a little easier to graph it that way. But what you're remembering is if it's 5/3 x, you're going up 5/3 every day. Okay. All right. So Dawson, let's say I've got an equation that says y equals minus 2x plus 10, right? Tell me what you know about these 2 numbers. What are they telling me?
So the plus 10 is going to be your y-intercept, and the negative 2 is going to be your slope.
Good. So when we say slope is negative 2, what does that mean? Like each day, what's happening?
Each day, basically, it's going down by 2.
Every single day, we're decreasing by 2. Whatever this thing is, we're going down 2 every day. Very, very good. All right, everybody feel okay about that? I know that's kind of a review. We're going to buzz over that and move on to this. So extracting information. So when we're looking at this y equals mx plus b, I get to look at it and name the things, boom, just like that. If I have y equals 3x plus 10, just like Dawson did, he would say, this is, the slope is 3 and the y-intercept is 10. He can look at it. We can look at it and just know it, right? But only if it's y equals. If it's not y equals, if it's 3y equals, or if it's 5y minus 3x equals, anything like that, we don't get to just look at the numbers and get to use them, okay? We've got to use y equals to do that. So what do we do if it's something different? Well, like in this example, this one says 6x minus 4y equals 8. And it says, what's the slope? So I know slope is the number in front of the x, and they're gonna, I'm surprised they didn't put 6 on here. This would really have made a lot of sense for them to try to trick you here. But the slope is not 6. It is not 6 because it's not y equals. So what do we do here? We solve for y. So we subtract the 6x over, boom. We're left with negative 4y equals 8 minus 6x. And you could put the x before, that's fine. Divide by negative 4, divide by negative 4, divide by negative 4. We get y equals negative 2 plus, I'll reduce the 6/4 to 3/2 x. And now I can look at this and say, there's my slope, and there is my y-intercept, my b, okay? Just remember, if they're asking you for slope and y-intercept, you gotta solve for y. It's as easy as that. Now, let's move on to the next slide. Okay, now we're gonna compare slopes. So there's 2 words they're gonna use, parallel. I always add an extra R, I think there's only 1 R in there. And then perpendicular. Okay, if a line is parallel to another line, they have the same slope. You can kind of see that, right? Like the rise over run, the rise, it's the same. So if it says parallel, then you're going to use the same exact slope. You're going to copy the slope of a line. Like if it says this line is 1/2 slope and this line is parallel, what's the slope? You're going to say it's also 1/2. Perpendicular is the negative reciprocal. And that is a big fancy word for flip. So the negative flip. So if I told you the slope of a line was 10, you would say, well, that's 10 over 1. So the reciprocal would be 1 over 10. And then since it's a negative reciprocal, we add a negative sign. These 2 lines of slope would be perpendicular to each other. So 10, negative 1/10, those are perpendicular to each other. So if it's parallel, same slope, perpendicular, negative, flip. Okay, you take 2/3, you flip it, you change the sign. If it was negative 2/3, you'd flip it, again, 3/2 and change the sign. Always different sign. If it starts negative, it's going to end positive. If it starts positive, it's going to end negative. All right. So Lauren, help me with this one. What are we going to do? It says, what is the slope of any line parallel to this line? What are we going to do here?
You have to isolate the y, so you're going to subtract 7x from both sides.
If I subtract 7x from both sides, I'm going to be left with this. And then what do we do?
You're going to divide by 9 to each number.
Okay. Do I care about this at all?
No, because you're finding the slope.
Yeah, that's the y-intercept. I just don't care about it. Sorry, y-intercept, nothing personal. I just care about the slope. So what's the slope of this line, the line that they gave us in the problem? What's the slope of this line?
Negative 7/9.
Negative 7/9. So what's the slope of the line parallel to that?
I was going to say 9/7, but I don't see that answer.
Well, they're nice. They should have put 9/7. They should have been brutally mean there and tricked you. So remember, parallel means the same slope.
Oh, Yeah, -7/9.
So we're going to go with that. If it said perpendicular, that would have been your 9/7 choice. Good. So we're going to go with B. All right, thank you. All right, this next one here, basically the same thing, but it says which one is perpendicular. So Aaliyah, help me with this one. What are we going to do to find the equation of a line that is perpendicular to this line that they give us? Perpendicular.
We have to get y by itself. So do we divide by 3y?
Just by 3.
Yeah.
Yep, we want to leave the y where it is. If we divide by 3y, then we got to divide everything by 3y, and all of a sudden we'd have 1 equals 4x over 3y plus 2 over 3y, and now I'm like, I regret what I just did. So yeah, just the 3. So when we do that, what's our slope going to be?
Hang on.
And you can give me a fraction too. Fraction or decimal.
Oh, wait. Yeah, 1.333.
Okay. So what is that written as a fraction?
My calculator is old and it doesn't convert decimals into fractions.
Okay. You're going to go, oh my gosh, when you see it. 4 divided by 3, 4/3. So 4/3 x plus 2. So the slope is 4/3. So just leave it as a fraction, okay? So if we're doing perpendicular lines, it can't be the same slope. So it can't be D, and it can't be E because E's 3/4. So what is the actual slope going to be of a line that's perpendicular to this?
-3/4.
-3/4. So it's going to be answer choice B. It's the only one with that slope. Okay? Just remember, solve for y. Once you're done, just copy the slope and go from there. Okay, so on this next one here, this one's basically asking the same thing, except it doesn't ask you for the slope. It just wants you to put it in the form y equals mx plus b. Slope intercept form. And it's real easy if you ever forget just to look at the answers. They're all in slope intercept form. So how are these different? They're all y equals. So we want to do y equals here. Now I'll show you the long way. You take away 9x from both sides. That's going to give you -y minus 5 equals -9x. Then we're going to add 5 to both sides. We're going to get -y equals -9x plus 5. Divide out that negative sign by dividing by -1. That just changes the sign to positive. And you get 9x minus 5. Okay, so answer choice H is correct. Anybody see a faster way to do this? What do you think, Emily?
Just add the y to the other side.
See how it's -y? We could have just added that y over, and then the y's by itself on the other side of the equation. And that would have been probably the faster way to do it. Okay, sometimes it's faster to do it this way, and sometimes it's faster to do it this way. Doesn't matter how you do it, as long as you get the right answer, we're okay. All right, so the next thing you're going to have to do is be able to take a linear function like this and match it to a table. It's really, really easy. Just remember you've got your inputs and then your outputs. So when you take your input number and you plug it into the equation, you're going to get your output number. So when I plug in a 0, I should get a 15. Well, plug in a 0 here, you get a 15. Plug in a 0 here, you get a 12. It's not that one. Plug in a 0 here, you get a 15. Plug in a 0 here, you get a 3. Plug in a 0 here, you get a 0. So the only ones that match so far are F and H. Just try another number. Try plugging in 1, see if you get 18. When you plug in 1 in D, you get 1 plus 15, which is 16, which is not what we're looking for. It's got to be H. Okay? Also, remember what we talked about at the very beginning, right? Dawson was helping us figure out like what the actual slope meant. Well, he was saying the slope was the actual amount that we change each day. And I can see that we're changing 3 each day. So the slope is 3. So I know it has to be one of these two. And then remember your 15 is your starting point, and you always start at x equals 0 or t equals 0. Okay, so it's got to be H anyway. So be able to look at a table and an equation and kind of match them together. It's a pretty easy one to do. Next thing with matching is a graph. You need to take the same information, your slope and your y-intercept, and be able to match it to a graph, okay? So look at the first one. The slope here is 3/2 or 2/3 or -3/2. I'm just looking at all the different choices that they give me. Guys, one thing to know when you're taking the test is don't necessarily read your answers across, like I'm pretending like I'm reading. This is not necessarily the best way to read these answer choices. It's actually better sometimes to read vertically. So read through it like this and you can see the differences. When I read this problem, I read through it like this. And I say, okay, I got 3/2 and 2/3 and -3/2. Which one matches? So I make a quicker decision that way. I know it's not negative slope, remember, because slope going up is positive, and that's a negative number, so that doesn't make sense. It's got to be not that number. And then I notice that my rise over run, 1, 2, 3 is rise is 3, run is 2. So it's got to be 3/2. So I know it's not H and it's not J, because those are 2/3, which would be more like this, 1, 2, 1, 2, 3. This would be 2/3 slope, right? Because it goes up 2/3. It's a little flatter, closer to 0. And then of course the y-intercept is down here at -3, so it would have to be one of these two or one of these three, and the only one that matches is F. Okay, everybody feel okay about that? We went through that kind of quickly. I'm just talking about the different types of ways you'll see linear functions. You'll see them as equations or graphs or tables and recognizing them as linear. And then being able to use mx plus b, and then in the other forms, making it y equals mx plus b, all very important things there. All right, let's look at the next thing here. All right, so here's kind of a thing that we've all done before, but it may have been a while, and it's surprisingly challenging for a lot of students. So let's go through a real simple way to kind of work through this problem. So if I said find the equation of a line given some sort of information. So find the equation of a line given that, and then they tell you some information about the line, okay? Usually it's one of these options here. It's goes through the points, you know, -2, 5 and 6, 1. Okay, that could be one example. Find the equation of a line that goes through these 2 points. Or it could say goes through the point 1, 4 and has a slope of 2. Okay, there's another way they could present that to you. So they could give you 1 point and tell you the slope. The third option is they're going to say goes through 1, 4 and has a slope that is parallel or perpendicular to another line. And they'll say, you know, 3x minus 2y equals 8. So in this case, they're giving you a point, and then they're saying it's parallel or it's perpendicular to another line. So we already know how to find the slope of that line that they give us, right? We just did that. So you would find the slope of that line, and then you would use that slope. Okay, so here's the order in which you would do a problem like this. Regardless of whether it's type 1, type 2, or type 3, whichever one of these 3 they give you, you still go through these steps. First thing you do is you find the slope of the line. So in the first example, right, we have to use the rise over the run. So that's kind of like you either use the formula y2 minus y1 over x2 minus x1 to find the slope, or you just draw a little picture. I kind of like this better, -2, 5 and 6, 1. And you just count the rise. Well, that's going down 4, so -4. And the run goes from -2 to 6, so that's 8. So my slope is -4 rise over 8, that's -1/2. So I prefer just drawing a little picture and counting, but if you know this formula and you want to memorize it or whatever, that's fine too. I just don't want to memorize as many formulas as I have to, so I prefer typically to do this. But either way, the goal is to find the slope first. So again, if they give you 2 points, you're going to use either the slope formula or draw a picture and use rise over run. That's what you'll do in the first case. In the second case, they give it to you. They tell you the slope, so you just use that number. In the third case, we have to find the slope of this other line and then steal the slope, right? Either copy it because it's the same, or use that negative flip, okay? And yeah, And that's what we do. So either way, we're going to find the slope first. So, okay, now we've got our slope number, whatever it is, we've calculated our slope, and they have to give you an X and Y coordinate, okay? Next thing you're going to do is take those two things and plug them into the point slope formula. So y minus y1 equals m times x minus x1. Now, the y1 and the x1 are your actual coordinates. I'll put a little 1 here for those. The x and y are your variables. You need to leave them as x and y. But the x1 and y1, that's where we're going to plug in our coordinate. We're going to plug in our m, we're going to plug in our y1, we're going to plug in our x1, and we're going to put it in the form that they request. So if they say, yeah, put it in this form, that's fine. We put it in whatever form they want. So the third thing is put it in the correct form. Usually it's mx plus b, but it doesn't have to be. So just watch out for your answers to see which one they want you to put it in. All right, a lot of talking. Let's get to some work here. Let's try one. So here's the first type of example, right? It says, which of the following is the equation of a line that passes through this point and this point in the standard xy coordinate plane? So they're asking us to find the equation. Which of the following is the equation? That basically means find the equation. And they give us 2 points. Boom, boom. So in this case, remember our first goal is always to find the slope. So what are we going to do? We're going to do y2 minus y1 over x2 minus x1, or we're going to draw a little picture, 1, -2, 4, 7, and we're going to use rise over run. We're going to kind of just count up and over. So I want you guys to do that real quick. I'm going to give you guys 20 seconds, set a 20-second timer. I want you guys to find the slope between the 2 points. Set a 20-second timer. Set a 20-second timer. All right, time is up. Ari, can you help me find the slope between these 2 points?
Yeah. Sorry. Give me a second.
Were you gonna use this y2 minus y1, or were you gonna do a little graph, a little picture?
I was drawing a graph.
Okay, so let's do it. Help me work it out. 1, -2, that's kind of down here, and then 4, 7 is up here. So sometimes when I'm doing this, guys, watch what I do. I put a 4 here and a 1 here, and then I'll label this as a -2 and a 7. See what I did there? I kind of like labeled the x and y numbers. So when I'm looking at the rise, right, you can see the rise is the distance here. What's my rise, Ari?
Wait. 9?
9. Good. I had to go up 2 to get to 0, and then 7 more. That's a total of 9. Over, what's my run?
3.
3. So 9 over 3 is my slope. That slope is 3. I would stop there, guys. You don't even have to do the rest, actually. The only one with slope 3 is G. That's our answer. Now, it's good for us to go ahead and keep working through that. So once we find the slope of 3, Ari, help me figure out the rest. Remember what we do then? We take our slope and our coordinate and we plug it into this point slope formula. Y minus y1 equals, do you remember the rest?
Wait. Sorry, hang on.
All right. Y minus y1 equals, remember it, m times.
Wait, is it talking about, wait, when you say y minus y1, is it the second one minus the first one, or is it?
There's no
What?
second and first, there's only a first. This is actually a variable. See how it doesn't have a subscript? It means it's an actual variable and you need to leave it as a y. We can't plug in, we don't want to plug in a y there. So this is our coordinate.
Okay.
So we have y minus y1 equals m times x minus x1. And if you actually think about it, if I had this equation right here, y2 minus y1 over x2 minus x1, what if I said solve for y minus y1? Wouldn't you multiply over the x minus x1 here? And it kind of looks just like that equation, but kind of a little different. But it's real similar. So it comes from the slope formula.
Okay.
So the slope is 3. The coordinate's 1, -2. We said y minus the y coordinate equals the slope times x minus the x coordinate. So let's plug in what we got. Y minus what?
2. So
Well,
it would be y plus 2.
it's going to be y plus 2, but I'm going to reinforce this with y minus because the formula says y minus, right? And we're going to plug in a -2. You're absolutely right. That's going to end up at y plus 2, but I'm just making sure everybody sees when your formula has a minus sign, you've got to put a minus sign. And then if your number happens to be negative, you're going to have two negatives that will combine to make a positive, okay? But just train yourself y minus and then whatever the number is. And then you'll kind of get to where you say, oh yeah, it's plus because it's double negative. And then equals, what's m?
9/3.
9/3, so just 3, right? We went ahead and simplified that, times x minus, what's our x coordinate?
Oh, 1.
1. Okay, so we get y plus 2 equals 3 times x minus 3. I just went ahead and distributed there, okay? Now, looking at my answer choices, I see that they're all y equals. So I want to do y equals. So what do I have to do to make it y equals?
You have to subtract 2 from the left side of the equation.
Exactly. And we'll do it to the right because it's an equation. We always do the same thing to both sides. And we get our answer. But just remember, once we found the slope was 3, we got to be done there. Now, if they had more than one equation with like this was 3x and this was 3x, then we might have to go this extra step. But this one was cool. They're all different slopes. So really, we just needed to know the slope. Okay. But you're going to see, we're going to do a couple of these and they're all the same. Find the slope, plug it into y minus y1 equals m times x minus x1, and then put it in the right form that the answers are. Okay. Thank you, Ari. All right, on to the next one. Which of the following equations represents the line in the standard xy coordinate plane that passes through 2, -3, and has a slope of -1/2? All right, Lauren, I want you to help me with this one.
Okay.
You see how this is the same type of problem? It says find the equation, what's the following equation, and then it gives us, you know, a point and the slope, right?
Yeah.
Same type of problem. What's our first goal?
So I'm going to use the formula, which is y2 minus y1 over x2 minus x1.
Okay.
So that would mean
You're finding the slope, right? Because that's always our first goal is to find the slope.
yeah.
Okay.
So could you just plug in the numbers 2, -3?
Sure, I could plug that in for here. There's a 2 and here there's a -3. But what about these? I don't have another coordinate. It only gives me one coordinate.
Oh, maybe you can draw it out.
You could, but I think you're missing one little. There's a little thing in here. Just read real carefully. Let's try it again. Which of the following represents the line that passes through 2, -3, and has a slope of -1/2?
Oh, you can just write the slope on there as for m.
They give you the slope. This is our favorite type of the 3 types. We don't have to find the slope, and we don't have to really compare it to another slope. We just get it. They give it to us. They're being very nice here. So we've got our first thing. We've got our slope. Now we're going to plug it into that formula. Remember the formula y minus what?
Y1 equals m, and then parentheses x minus x1.
Good. Now remember, this 2 and this -3 are going to go where in this formula?
The -1/2. Oh, the 2, -3. The 2 is going to be x1, and then the -3 is going to be the y1.
Very good. So that'll be our -3. So when we write this, y minus -3 turns into y plus 3. And then we've got our -1/2 times x minus 2, sorry. Now, I should have stopped here, right? They told us the slope was -1/2. I know that the only possible answers here are G and H, which is good to know. Like worst case, if I was running out of time, I just make a guess between those two. All right, but now we're here. Y plus 3 equals -1/2 times x minus 2. What do I do from here?
You're going to subtract or divide by 3.
Well, do we subtract or divide? What's happening here already?
Divide, yeah.
Well, what operation is holding these two together?
Yeah, subtract.
Well, what operation do you see here?
Positive or addition.
Positive is addition, right? So these are glued together with addition. The way to break them apart is with subtraction, which is the opposite. Okay. All right, so subtract 3, and then we'll subtract 3 from here. We get y equals, now what should we do here? I see this 1/2 sitting next to a parentheses. How do I deal with this number sitting next to this group?
You're just going to multiply by x and -2.
Good, we're gonna kind of distribute that -1/2 inside there, right? So we get -1/2 x, and then 2 negatives multiply to be a positive, and then 1/2 times 2 is 1. So we get a +1. We take away our 3, and we get what? What's 1 minus 3?
-2.
And we get our answer, G. Now, guys, I'm going to show you a little twist on this, okay? If this doesn't sit well, or if you're just into something different, you want to try something different, I'll show you an interesting way to do this, okay? First of all, slope is -1/2, right? So it's got to be one of these two equations. There's no doubt about it. But it goes through the point 2, -3. Well, if a coordinate is part of the line, it will what we call satisfy the line. It will make the line happy. It will make the line true. That means if I plug in a 2 and a 3 into x and y, it will make sense. So let's plug in -3 for y. We get -3 equals -1/2 times the x, which is 2, minus 2. See what I've done? I've taken G, and I plugged in the -3 and the 2. Oops. When I do that, it simplifies to be this, right? I multiply that negative times the positive, I get a negative. And then I add my negatives together, I get -3 equals -3. That tells me that yes, 2 -3 is on the line. Okay, so G contains that point. So it's got to be the answer, but I could check H if I wanted to. Same reasoning. -3 equals -1/2 times 2 plus 4. And when I do that, I get -3 equals 1. -1 plus 4, which is +3. It doesn't actually work. It does not contain that line. If I were to draw H, it would not contain the point 2, -3. It just doesn't contain it. So there's an alternate way to do it. Just plug in the point into the equation, and it should say something true. Okay. Okay. Let's see. This one we're going to buzz over pretty quick here. Just notice that this one is parallel to this other line. So we're going to use the slope of -2. Because it's parallel, it's the same slope. So we're going to steal the slope from this other line because it's parallel to it. And then we're going to use the coordinate 0, 7. Okay. All right. So Dawson, help me with this. Once we found our slope and we got our coordinate, what am I going to do here?
Since we got our slope, we're gonna see which other ones I guess have the same slope in the answers. And then with our coordinate, our y coordinate, what I would look at is since it's 0, 7, I'd look for a +7, and then I just find that one and know that it's G.
Okay, cool. So here's what Dawson did. Good trick there, Dawson. He recognized that this coordinate 0, 7 lies on the y-axis. So it is the y-intercept. They're telling you that the y-intercept is 7, right? So that means we should have a +7 there. We don't have, this is the one case where we don't have to do the y minus the y coordinate equals m times x minus the x coordinate. Because what happens is when you add this 7 over, when you distribute here, you get negative 2x plus 0 plus 7. It makes a plus 7 anyway. So he recognized that this is already the y coordinate of the y-intercept, I should say. So he knew that that had to be a plus 7. Now, if this was 1, 7, you couldn't do that. You'd have to go back and use this formula, okay? But this is a good reminder that sometimes they give you that y-intercept very sneakily. If they said 0, negative 2 was on the line, you would say, well, that's my y-intercept because the x is 0. So I'm on the y-axis. Okay, very nice. All right, on to the next topic, systems of equations. Okay, these problems tend to take students a long, long time to do, and they shouldn't. We should get good at these where they're fast. Okay, so when we're talking about systems of equations, there's 3 methods: elimination, substitution, graphing with your calculator, or guess and check. We'll kind of talk about that one as well. With word problems, guess and check can be done pretty well, but these 3 are the standard methods. So elimination works when you have something like this. Okay, now remember, this is a system of 2 lines, right? A system just means 2 or more equations, and these are both lines. Remember we talked about this being a line, x and y and a number all together. That makes a line. So we can use what we call elimination. Now, I know elimination is a good choice here because when I add the 2 equations, which is what I'm going to do, when I add these 2 equations, 2x and negative 2x add to be 0. And that's what I want to do. I want to add these equations to where they make 0. So when I do that, they basically cancel out. And I'm left with 4y equals 22, which is now a single 1 variable equation which I can solve. Divide by 4, I get y is equal to 5 and a half, or 5.5. Now, I take that y value, I go back, I replace the y value in here with an actual number, and then I've got a 1 variable equation that I can solve for x. Okay, that's the strategy here. Again, if you had, 3x minus y equals 16 and x plus y equals 10, this would be a good choice. If I add the 2 equations, what happens to my y's? They go away. In the last case, my x's went away. In this case, my y's went away. But it happens when you have 2 of the same variables with coefficients that are the same but opposite signs. So 1 positive, 1 negative. That's when you add the 2 equations, it gets rid of one of your variables, you solve for that variable, then you go back and plug it in. Okay? All right. Would elimination be a good choice for this? Okay. Leah, do you think elimination would be a good choice here? Yes.
No,
Not a good choice. Why not?
because it wouldn't completely cancel each other out.
Okay. So what I'm going to rephrase that is, I don't think this is a great choice for elimination because it's not like the perfect setup, right? When I add these, the variables won't go away. But can I make it to where it's a good choice? Can I fix it? How do I do that?
No idea.
No idea. Awesome. I love it. So here's what you can do. Here are the rules with elimination. You can multiply a single equation by a number, right? All the way across. So what I'm going to do is I'm going to multiply this bottom equation by 3. You see why I might do that, Leah? Why might multiplying this by 3 be a good choice? I'm going to hit it here, here, and here.
To get 3x so you can cross it out.
That's right. So my first equation doesn't change. My second equation becomes negative 3x plus 36y equals 6. And now when I add the 2 equations, my x's disappear. Okay? I get 42y equals 18, and I solve for y, and then I go back and plug it back in and then solve for x. Okay? That's elimination. Basically, when you can make one of your variables disappear, even if you have to multiply one of your equations by a number, that's a good way to do it. Okay? Now, what if I had this instead? What if I had 5x minus 3y equals 12, and I had negative 2x plus 5.5y equals 2. Okay. Dawson, help me with this one. I've got this system of equations here. I'm wanting to use elimination. Would I be able to use elimination on this one?
There's probably a chance you can make it into elimination, but it's gonna be, you're gonna have to like get a number that you can multiply both the equations by to where they equal out. But
Yeah. So what would I do? Like, are the y's going to be a good choice here? Like, would I want to make my y's disappear? I got a negative 3 and a 5.
I'd probably make the x's disappear because you can do, I'd say that you could do the 5 times, you could do the 5 times negative 2, and
Okay.
then the negative 2 times 5. And that would, or wait, no, sorry, 5 times 2, and then negative 2 times 5. So that way you have a 10 and or 10x and negative 10x to cancel out. And then you have the y's in the.
So we're going to multiply this whole equation on top by 2. And what that's going to do, I won't do the whole thing, but I'll just show what you're talking about. That's going to give me a 10x, right? And then if I multiply the bottom equation by 5, that's going to give me a negative 10x with a bunch of stuff, right? Then I can add and my x's will go away. So it's still possible to do that. And I still think like it's probably still the best way to go. If you've got your x's and y's lined up, and the numbers aren't super crazy, like 2s and 5s are easy to make a 10. I still think this way is probably the way to go. It's just a little bit more work. Yeah. All right, nice work, Dawson. Okay, let's try the next method, okay, substitution. This method works by solving for one variable in the equation. So like if I had 3x plus 2y equals 10, and then I had that y was equal to x plus 6. If I was solving this system and I notice that one of my variables is already solved for, right? The y is by itself. This is going to be what I'm going to do most likely. Okay. What I'm going to do is I'm going to substitute. I'm going to replace in the equation that is not solved for. Okay. It's the one that's not solved for. You see how there's a y right there? It's 2y. Well, the same thing, y is the exact same thing as x plus 6. They are equal, right? That's what y equals x plus 6 is saying. It's saying they're the same thing. So that means I can trade them out, right? If you give me y dollars, I can give you x plus $6, and we just did a fair trade. They're equal. Well, if they're equal to each other, then I should be able to replace them and nobody care. So that's what we're going to do. We're going to do a switch. We're going to take the first equation, 3x plus 2y equals 10. And we're going to write it out like that, but I'm going to leave a little blank here. And instead of putting a y like it has, I'm going to replace that y with whatever y is equal to. I have to make a fair trade. But I can make this trade here. I can put in x plus 6 because y and x plus 6 are equal to each other. So when I make that substitution, the whole goal in any of these methods is to try to get it to where there's an equation with only one variable. So if there's only x's in this equation, I'm going to be able to solve for x then. So of course I would distribute. That's going to give me 3x plus 2y plus 12 equals 10. Or sorry, 2x. Sorry, I said y, but it's just x. And then I combine my like terms. I get 5x plus 12 equals 10. Then I subtract my 12 from both sides. 5x is negative 2. Divide out the 5, and I'm done. X is equal to negative 2/5. Okay. Now, how do I go back and find the y? It's simple. I already have an equation that says y is equal to the x number plus 6. And I just found the x number. So I plug it back in there, and it says that y is equal to negative 2/5 plus 6. Now that's 28/5 if you're really wanting to know the answer. And this solution, this x and y pair, are on this line and they are on this line. They satisfy both equations. When I plug them in, both equations work. Now, what that means visually, if I'm looking at a graph of these two lines, what it means is it's the intersection of these two lines. Okay, that's where the dot is on. If it's on both lines, then it's where they're crossing, right? So a couple ways to think about it. This coordinate, -2/5, 28/5, is a solution to both equations. That's one way they'll phrase it. They'll say, find the solution to the system. And again, the system is all the equations kind of put together, okay? Find the solution to the system. Or they'll say, find the intersection of these two lines. That's another way to put it. It means the same thing. Or they can say, find the point that satisfies both lines or satisfies the system. Satisfies just means it makes it happy, it feeds it like what it needs and it's good, and that's just what that coordinate does. Okay, so that's the substitution method. Now, in that last example, I don't even remember what it was, 2x plus 3y equals 10, and I don't know, x minus 6y equals 8. This is a good example of when you could do both. Like I could do either one here. I could make my y's the same, right? I could double the first equation and it would make a 6y, which would add to this -6y to eliminate. So I could use elimination there. Or I could just solve for x. See how easy it is to take this and just add the 6x or the 6y over? And you get that x equals 8 plus 6y. It's pretty easy to solve for x there. Then I could take that x and plug it into the other x in the equation. So either way, sometimes there's multiple ways to do it and you can kind of pick your favorite. All right, that's substitution. Third option, graphing. Usually we do graphing when it's y equals, when they've solved for the y's. This is a great time to use solving or graphing. Or if you just don't like solving these any other way, this might be your best bet. Because we've already talked about how to get y by itself. We already know how to do that from previous examples today. So you know how to get to here from another equation. You could take those other equations that are more likely to solve with elimination or whatever and solve for y in both, and now you've got a system that can be solved by graphing. So this may end up being your favorite method regardless, and you can always use this method if you like it, okay? There's times when other methods might be like encourageable, like you should try it this way because it's really kind of set up for that. But then still, if you don't like them, then go with this method. I'm okay with it. I want you guys to do the best method that you are good at, okay? All right, so here's what I'm gonna do. I'm gonna show you on my graphing calculator, okay? So I'm gonna graph both equations. I'm gonna graph this first one, I'm gonna graph this second one, and then I'm gonna calculate the intersection point of the two. Okay. So I take my graphing calculator, I go to y equals where I graph things, and I start to graph them. So the first one was 5x minus 7. And the second one was negative 1/2 x minus 4. And then I graph them, boom. Now my zoom's a little messed up. See how I've got like a weird zoom going on? So I'm gonna hit zoom 6. That's zoom standard. That will get me back to my regular thing there. Now I can guess on this. Sometimes you can look at the answer choices and know which one it is based off of like just looking at them. Like this one looks like it's like almost 1, but not quite 1. So maybe like 1/2 and then -1, 2, 3, 4, -4.5 or something. As a guess, okay, I'm gonna put what I think it is. I think it's 1/2 and then -4 1/4. That's my guess. Not really sure, but that's pretty close. Well, here's what we do. It's a very simple keystroke, all right? And I'm gonna write it down for you actually. You're gonna type the second button. then the trace button. Now the trace button is actually going to be the calculator button because it's the second function of the trace button. See where it says calculator in blue? So second calculate is really what you're doing. Second trace. And then you're going to hit 5, the number 5. You're just going to type in the number 5. And then you're going to hit enter, enter, enter. You're going to hit enter 3 times. Now, in another day, we may talk about how you'd hit enter, enter, and then the third thing, you might have to do something before you hit enter, but we're just going to go with enter, enter, enter. That's how we're going to learn this. Second, calculate 5, enter, enter. All right, so here we go. Second, calculate the number 5. You just type in the number 5, and then you hit enter, enter, enter. And it's going to give you the answer there. Negative, or sorry, 0.545454 and negative 4.272727. So this one's a little funky, strange. Now those might be fractions. In fact, they are fractions, I think. So if I wanted to know what they were, I could go back to here and do 0.5454. And you just keep doing 5 4s until you get off the screen and your decimal disappears. See my decimal on the left there? It's about to disappear once I go off the page. And then I hit enter, and then your good old friend math frac. Math, enter, enter. It's 6 11s. Okay. And then the other one I think was negative 4.2727. And then same thing, hit 2 7s until you're off the page. Once you're off the page, you can do math frac. Let's say it's negative 4711. So in case they were answers that were like that, then you could do that. Okay, not too bad, right? If you can solve for y and plug it in your calculator and get the answer, you'll get it. Now, one thing to talk about is if your x number of your solution is too big or too small, it won't show up. Just your x number. The y number, the calculator is fine with. But if you go to window, you can change this to like negative 1,000 or, and then make this, 10,000 or whatever. You can change your window to take care of that. So you can just make these really big numbers and then you won't have any issue. So as long as your numbers are really big like this, you'll be able to find it. Okay. So remember, zoom 6 gets you back to your normal window. All right, so that's the graphing technique. The last technique I want to talk about is this guess and check. It's more for word problems. You'll see a problem that says, I sold $5, hats and $12 shirts at a fundraiser. I sold a total of 20 items and made whatever, $170. How many hats did I sell? Well, you could assume that you sold 5 hats and see if it works with all the answer choices being, 5, 10, 15, 17, 18, whatever it is. You could guess and check here, okay? So with word problems, sometimes you can guess and check. Sometimes you can't, but sometimes you can. All right, so let's try an example here. This is our elimination method. So I'm gonna give you guys, I'll give you guys 90, we'll try 60 seconds, so we'll go a little longer if we have to. So I want you guys to try to solve this problem. You can use any method you want to, but might try elimination because it's kind of guiding you in that direction, but set a 1-minute timer. Let's go ahead and solve this. All right, let's go over this one. All right, Emily, you want to help me with this one? Did you use elimination?
Yes.
What did you do?
First, I multiplied the first equation by 2.
So you
that the x's
multiplied
could-
this equation by 2. Good. And why did you do that again?
So that the x's could cancel out.
Good. You see how she does that? Her x's are totally going to cancel out when you add. So when you added, did you get 5y equals 20?
Yes.
Divide by 5, you get y equals 4. Did you stop there and find the answer? Or did you go back and find x?
No, I went back and found x.
That's okay. But you did a little extra work. The only one with a y value of 4 is a, so it's got to be our answer. Always good to check. Doesn't always help, but sometimes it's nice when you're like, ah, it's 4, I'm good. And then sometimes you're like, well, I don't feel 100% sure. I think I better just make sure. And that's okay too. So what did you do after here? After you found out that y was 4, how did you find the other number?
I used the first equation because it looked easier.
Okay.
So I just plugged in 4 there.
So you plug in 4 for the y value, and that will help you find the x value. Boom, x equals -3. Anybody do it a different way? Did anybody solve for x? It actually wouldn't have been that bad of a way to go. You could have subtracted the 2y and you would have gotten 5 minus 2y for x, and then you replace that x with that 5 minus 2y. If you like this method better, this would have been a great time to use it, because really this isn't bad. -10 plus 4y plus y equals 10. You get 5y equals 20. You still get y equals 4. It's the same. It'll work the same way. Did anybody use guess and check? That's what I did. I looked here because I wouldn't, I tried it and I was like, okay, x plus 2y should equal 5, and it did. And then I tried it here, -2 times x plus y equals 10, and it did. So I knew this was the solution to the system because it worked for both. So again, you've got options here. Remember, if we would have graphed it, could have worked as well. Would have subtracted the x from both sides and then divided by 2. So 5 minus x divided by 2, that would have been our first equation. And then here it would have been y equals 10 plus 2x. If we would have graphed both of those and done the second calculate thing, we would have gotten that as well. So again, it's a good reminder that you've got options here. You can choose the one that you like the best. It's good to be fluent in all of them, but if you're forced into just doing it the way you like, then that's okay too. All right, a system of equations is given below. What's the value of b in the solution to the system? All right, let's take a minute to work this one. Set a 1-minute timer. All right, another couple seconds. All right, let's go ahead and go over this. So Aaliyah, will you help me with this one? Did you use substitution here?
No.
What did you do? Saw a graphing?
No, I used elimination. explanation.
Okay, so tell me how you did that.
Well, sorry,
You didn't add the two equations because you would have gotten 2a equals 4b plus or minus 6.
yeah,
You didn't
no,
add them.
no. I multiplied the second equation by -3.
Okay, -3, -3, -3. That will totally work. When you do this and you add, you're going to get -2a equals -10. So a is going to be 5, right? And then you go back up and you plug it into either equation. It doesn't matter. We'll just do the first one. And you just kind of solve from here. 12 equals 3b, so b must be 4. And that's what they're asking us for. What is the value of b in the solution? Perfect. That's great. Anybody use substitution here? Right? I see one person using substitution. What you would do is you would say, okay, well, a is the same thing as 3b minus 7. So let's replace it in the second equation, right? So I'm going to take my a and I'm going to replace it in the second equation with that. Some people call this just equating them, and that's kind of the same thing, but it's really just substitution. From here, we would solve, take away the b from both sides, you add the b to both, or add the 7 to both sides, you get 2b equals 8, you get b equals 4, which is ultimately what we're trying to do. Did anybody graph this? It's kind of already solved for. The only problem is we're graphing y equals, right? Y equals. So this is like your y, which it's trying to be like your x, and this is like your y. So if you did graph them, you would actually use your y number, your x number, even though this is your y number, because the way we've got it written, it's a solved for, and that's like y. So we could have graphed these, and we would have gotten b equals 4. Okay. Did anybody use guess and check? I mean, I suppose guess and check would have worked here too. If you plug in 4 for b, you get a equals 12 minus 7, and a equals 4 plus 1. You get a equals 5 and a equals 5. That would have worked too, actually, but you would have had to guess all those different random numbers. Okay. Moving on. All right. Same thing here. Portions of the graph represented by the functions blank and blank are shown in the standard coordinate plane. Although only a portion of each graph is shown, the domain of each function is all real numbers. If it can be determined at what point do the graphs intersect? Obviously, if they showed you a graph, then you'd kind of know the answer. So anyway, I'm going to give you guys 1 minute to try to solve this one. Set a 1 minute timer.
For how long?
Set a 1 minute timer. Okay, keep working this one. All right, let's go over this. So really, I think if you had a test sitting in front of you, I would almost just draw this thing. You know what I mean? Like, I know it's kind of like cheating, but whatever. I think it's 1.5. Now 1.5 isn't, oh, it's 1.4. Yeah, I can see it there. I bet $1 on this. It's 1.4. You know what I mean? Like, I feel pretty strongly that it's, what are the other choices? -1, 5. I mean, I just don't see that working. 2, 5, 1, 2, 5, maybe, but I can still see that that's not going to hit it. And then 4, 1. I mean, come on. I thought that's not even close. Now, cannot be determined might be a possible choice, but I feel like that one's pretty clear. You could just kind of guess and check that one. Now, what I would do with -2x plus y equals 2 and x plus y equals 5, I don't know what I'd do. I think they all three work really well. I can solve for y really easily in both of them. Y is 5 minus x in the second one. Y is 2 plus 2x in the second one. I think graphing is really, really easy there. I think elimination is really easy. You either eliminate your y's by changing the sign of everything, right? Multiplying by a -1 and then adding. Or you just double the bottom equation, 2, 2, 10, and then you add your x's go away. I also think that solving for y would be really easy as well in either one. So like a substitution would really be easy. X is just, or actually I would do y is just 5 minus x, and then I would replace the y with that up here, and it's really easy. I think this one, you can pick any one, and I don't think you made a mistake. I think all three are great. But this one just, man, it's so easy just to keep that line going. It looks like 1, 4. So I would go with that maybe too.
So I used the elimination,
Uh-huh.
and I did the one where you added or you multiplied the 2 to the bottom one.
Okay.
But after I found out y, which was equals to 3, I wasn't sure what to do next.
Okay, so let's go over that. You doubled your bottom equation, right?
hmm
So when you added, you got 3y equals 12.
I got y equals 3, or yeah, 4. Sorry.
4? Okay.
Yeah.
So you divide out the 3, you get y equals 4. So from there, first of all, I might look at my answer choices and see the only one that has a 4 is this one. Or to make myself sleep better at night, maybe I go back and plug it in. So the strategy is once you find the value of one of your variables, you pick an equation. It doesn't really matter which one. I actually think the original x plus y equals 5 would be the easiest. And you replace the variable that you just solved for with the number that you found it was. See what I did there? And then we solve for the variable that we haven't quite yet found, and we get that x is 1.
Okay.
Now, what if you didn't choose that one? What if you picked the other one? It shouldn't matter. Okay, we found out that y is 4. What if you plugged it into -2x plus y equals 2? Or when I plug that in, what do I get? Just what would the next line read?
You would subtract the y.
Well,
or,
remember, we know that y is 4. So in math, anytime you know the value of a variable, you stop using the variable anymore. Remember, variables are for numbers that we don't know.
mhm.
Like I wouldn't say, how many fingers are on your hand? Oh, there's X fingers on my hand. Like, no, I would just say there's 5 because I know the number. So once you find out the value of a variable, you always plug it in. There's never a time where that doesn't do you right. So
Okay,
plug
so
in 4. So
yeah.
rewrite it as this. Okay, that's what the next step should be. Regardless of which equation you choose, you should always then plug that back in.
Okay.
And now look what we've got. We've got an equation that we should be able to solve for x. So how do I solve for x in this?
You can subtract 4, and then you would get -2, and then that would be just 1.
Yeah. Right, you get -2x equals -2, and that must mean x is 1. Now, what if you use the equation where you doubled the x and the y? It should work the same way. You plug in your 4, right? Can you see how that 2 times 1 plus 8 makes 10? So x would be 1. So either way you do it, once you solve for the first variable, once you get a number, you go back and you replace it in the equation, right? With whatever the x is, you replace it with that number every time. always. Now, if you're doing substitution, you've already got like y solved for. When you get down here and you get the, x is equal to 3, it's obviously the best choice to plug it into this one because you just get y equals 3 plus 1 and y is 4. You could plug it into the other one, but this one would make the most sense. Whichever one you solve for, that's where you're going to go back and plug it in once you find the value of the x. Just because it's like y equals, and you just do the math and you're done. You don't have to move things around and solve. It's like already solved for. Okay. All right. Things to watch out for in system problems. Okay. First thing over here. Okay. I'm calling this easy substitution. So like this problem is so easy to do because look how easy it is to solve for a. A is equal to 3/5 because you divide both sides of the first equation by 5. And then you're going to substitute that back in. It's almost like you can almost miss it because it seems like it doesn't look like a normal systems problem because it doesn't have the B and the A. It just has the A, but that's okay. Just add your A and you're good. Just add the A in back here. That's what I'm saying. Solve for A and then add it back in. Okay, so watch out for easy ones like that. And then also look out for questions that they can answer. So notice how it doesn't say find the coordinate. This is actually saying find the sum of x and y. So find your x, find your y, then add them together. Okay. So just things to be aware of there. All right, so here's a system word problem.
Do you mind going over that one again about the x and y?
Oh, this x plus y?
Yeah.
Yeah, I kind of buzzed over that pretty quick. So it's saying given this system, they declare a system. They say here's a system, and they say what is the value of x plus y? So you're supposed to solve the system. Remember when you solve the system, you find an x number and a y number? So let's pretend that x was 1, 2, 3, 4, and y was 1. That actually is the answer. I just kind of got lucky. So when you solve the system, you'll get 4 and 1.
So solving the system is using one of those methods, and
Yep.
then
From there, they can ask you a question that's not just, because in all the other examples, they're like, find the value of x, or what is the coordinate? See how they're asking for the coordinate on this one? And here they're asking for one of the values of the variable. Here they're asking for the coordinate. And so they can ask different things. One thing they could ask is something random, like what's x plus y? Right? I've seen them say, in this system, what's the value of x squared minus 3y? And you would just have to find what x is and what y is, and then just plug them in. So first thing is always to find your x and y through solving the system, like with one of those 3 methods. Then answer the question, which is either like usually what's the value of one of the variables, or what's the coordinate, or what's the solution, right? Both variables together, usually written as a coordinate like this. Or they could ask something different. So just be expecting they could ask anything about x and y. They could say, what's the difference between x and y? And you'd have to say x minus y equals whatever. In this case, it'd be 3, right? 4 and 1, the difference is 3. They could just be ready for some sort of question, not just find the value of the variables. Okay. All right, let's look at this. These are called systems word problems, and they're just word problem system type problems, okay? So the first thing you got to know is that you need to write the equation, okay? You're going to have to actually write the equation here. Now, like I've got down here, guess and check can be a really strong strategy, especially in these word problems. Because the time it takes to work these out, to come up with the equations and then solve the system and then go back and answer the question, it might have been faster just to use guess and check. Okay? All right. Dawson, are you there? I want you to help me write these into equations, okay? It says the product of two positive integers is 78. The greater integer is one more than twice the lesser integer. What is the greater integer? So let's try to write this as an equation. The product of two positive integers is 78. So how can I write an equation out of that?
So first of all, you're gonna need to do equals 78 because you have two products, or the product of two positive integers. So it's gonna be multiplication.
Okay.
Um,
And what are we multiplying here to make 78?
two positive integers, and it says the greater integer is one more than twice the lesser integer. So so basically, I mean, I have to calculate this out and try and
That's all right. Just help me write the equation. How do I write the product of two integers? So like, what would I put over here? Blank blank equals 78.
just I don't know, x times y for now.
Sure. Yeah,
Or
well,
x.
you know, you could do A times B equals 78. You call them anything you want to. L times G, lesser and greater. I mean, that's not a bad idea.
Yeah.
But it doesn't matter what you do. You just got to know what product means and make them equal 78 together. Now, what about the other one? The greater is one more than twice the lesser. How do you write that? Should we write G and L? I feel like G and L might be the way to go here. The greater integer is one more than twice the lesser integer. How do we write that into an equation?
Yeah, just one more than lesser. So, I mean, I don't really know how I would write that one, honestly. If it were me doing this equation, I'd most likely guess and check.
Okay,
But
that's okay. No, I think that's a smart idea, actually. Let's try to use keywords here. The greater is. What does that start me off with? If I'm writing an equation and it says the greater is, what does that sound like to you? Greater means G, right? So G, and then what does is sound like in an equation?
the greater is greater than the lesser. So
Well, what does the is mean? Like when I read this, I can say that X is 7. I can read that as X is 7.
yeah. Oh, so
What
the
is this?
greater is basically equal to
Equal to one more. What does that sound like?
plus one.
Plus 1, kind of at the end, actually, yeah.
Times
And twice the lesser. So twice the lesser would just be 2L, right? One more than twice the lesser. I think that's it. There's our system. So with these word problems, again, you're going to have to write the equation, and that can be really challenging, right? Dawson, I agree with you. I think guess and check's the way to go on this one. Especially when I start solving this system, we're going to see really quickly that it's the way to go, okay? But let me show you anyway. This is one of our harder systems, but we get G times L equals 78 because the product is 78. The greater is one more. Usually one more actually goes on at the end, just like one less would go on at the end, then twice the lesser. So here's our system. Guys, it's solved for G, right? That tells me I should probably substitute. So G times L equals 78, but instead of G, I'm going to replace with what the other equation tells me G is. So G is 2L plus 1. Now, here's the problem. I'm about to do this. Multiply inside. I get 2L squared plus L equals 78. This thing is a quadratic. It has a squared and an L. I'm going to have to use a quadratic method here. I'm going to have to get everything to one side, so minus 78 equal to 0, and I'm going to have to factor this thing. Yikes. Can we all agree that we don't want to do this? Yeah, let's just agree to agree on this one. We don't want to go down this path. What we want to do is recognize this as a simple problem. It says, what's the greatest integer? Well, let's say the greater integer was 7. Let's try it. If the greater is 7, what's the lesser? Well, it says the greater is one more than twice the lesser. one more than twice the lesser. So if the lesser was 3, twice that would be 6. The greater would be one more than twice that. So there we go. What is the greater integer? If it was 7, then this would work. The greater is twice more than the lesser. We got that. But is the product 78 when we multiply them? No. I need it to be bigger, which tells me that G is too small and F is too small. So then we jump over to J. Let's try 13. If the greater was 13, then what would the lesser be? Ari, can you help me with that? What would the lesser be? If the greater number was 13, what would the lesser number have to be?
Uh,
This one's hard. The product of these two numbers should be 78. So you can use that. What number times 13 is 78?
hang on. 6.
Okay. Now, is that also true about this? Is the greater integer one more than twice the lesser integer? Is that still true on that one? Is the greater integer one more than twice the lesser? What's twice the lesser?
Um,
The lesser number is 6, right? What's twice the?
It's wait. Wait, you're asking for twice the lesser?
Mhm.
Oh, 12?
So is the greater number one more than twice the lesser?
Yeah.
One more than what twice the lesser would be? So this one does it, guys. That's it. That's our answer. 13 and 6 work. I think it's much better, right, than getting into a quadratic. We haven't even gotten to quadratics. We're going to talk about them next week or the week after. But yeah, I think this is just the way to go. I don't think going down that other route is going to be kind of nasty. All right, let's try another one. At the winter weather store, the price of one hat is $12 and the price of one scarf is $14. Jovan spent $128 to buy 10 items, a combination of hats and scarves. How many hats did he buy? Okay, first off, let's try this real quick with coming up with the equations. Now, in this type of problem, there's always going to be two types, a money equation and a total number of items equation. Okay, so just let X equal the number of scarves and Y equal the number of hats, or if you're really smart, maybe it's better to say S is scarves and H is hats. That way we don't have to like keep track of it. So how do we come up with a total items equation? Well, we know that the number of scarves plus the number of hats is equal to the total number of items that were sold, and there was 10 of them. So the very simple equation is S plus H equals 10. That's very simple. The number of scarves, which is S, plus the number of hats equals 10. Now the slightly more difficult one is the money equation, right? How much money did I make today? Well, I take the number of hats that I bought times the price of each hat, and then I take the number of scarves times the price of each scarf, and I take those two numbers and I add them together. So what we're doing is we're saying the price of a scarf is 14. So 14 times the number of scarves that I bought, plus $12 times the number of hats that I bought, equals the total amount of money. And that is where you get your secondary equation. That's your money equation. This is your items. This is your money. From there, you solve the system. I won't even worry about going through it. I think you guys have done enough of these solving. You'll know which one to do, okay? Now, can we use guess and check? It says how many hats did he buy? Well, let's say he bought 4 hats. Let's just assume. Let's guess and check. 4 hats, $12 a piece, that's 48 bucks. 10 items, that leaves 6 scarves. 6 scarves is $84. That is a total of 132 bucks. That is more than we spent. Well, does that mean we need more hats or less hats? Right? I'm saying we bought 4 hats. Well, a hat is cheaper than a scarf. If I had sold 1 more scarf and 1 less hat, I would have made more money. Sorry, less money. So I need more hats. If I only sold one hat and the rest were scarves, it wouldn't be enough money. So then I'm going to try D, and I think D is actually going to work because the price difference is $2. So every time I trade out, I lose two. That'll put me down at 120. The guess and check would be a good option. Okay. All right, this one is the same kind of thing. We just have to come up with the formula. So this is our last task of the day. If we can get this formula, we're done for the day. So I'm going to set a 90-second timer, and I wanted everybody to see if they can come up with an equation or a system or something. See if you can figure out how this one works. Set a 90-second timer.
For how long?
90 seconds.
Okay.
Okay, that's time. So first of all, the first one is the depth of a pond is 180 and is being reduced by 1 centimeter per week. So the same amount of reduction each week means it's a linear function. So the depth is going to be 180, there's my starting point, minus 1W. You don't have to use W, you could use X and Y's, but I'm going to use W. 180 minus W. The depth of a second pond is 160 and is being reduced by a half a center per week. So the depth of the second equation is going to be 160 minus 1/2 W. There's our system. We either set the two D's equal to each other to find out when they're the same depth, or we do elimination, or we do substitution, which is really what I kind of had said first to do. Or we can graph both of them and find out what W is and D is, and then we make sure we answer the question. Okay. It's going to be, see how this one's going down a full centimeter per week, and this one's only going a half a centimeter per week. You see how it's catching up by a half a centimeter per week? Do you guys see that? It's getting closer every week by a half a centimeter because the one is going a half a centimeter faster. So it's got to make up 20 centimeters. It does half a centimeter per week. That's 40 weeks. So sometimes these can be done in a creative way, like the distance between the two things and then how much faster it's gaining on the other one. It would take 40 weeks. So there's a creative way to do that one. But really, solving this system is going to give you W equals 40, and then the D will equal 140. Depending on what they ask, how many weeks, that's W. So W equals 40. If it said what depth would they be at, that's when you would use the 140. But because it's not asking that, we're using the 40. Okay.